Today we'll be talking about the first work measurement technique. There are four common work measurement techniques, like these are work sampling, time study, PMTS, predetermined motion time study, and the standard data method. So in the first two categories, as I told you, these two studies are conducted actually in the shop floor. So work study man will be visiting and conducting the studies in the shop floor, while other two studies like PMTS and standard data method, in those two cases the data bank is used related with the different actions and the activities needed for completion of the job, for compiling the time required to complete the job using the work measurement technique. So that is more convenient, and it can be used to quantify the time a job will take even before it is actually done. So that is the good side of those other two techniques, but those are little complex and may not be equally effective in all the situations. So today we'll start with the work sampling technique. As I said, today they will be talking about the work sampling. This is one work measurement technique. So there are different applications, and the work measurement is helpful in number of ways, including identifying the effective and ineffective time which is being consumed in a particular job, and and it can, apart from that identification of the ineffective time, the work measurement can also be used for setting the time standards, and setting the time standard or standard output is extremely useful in number of ways in the industrial conditions. Okay, so this is a more popular, useful and very clean method of the work measurement. While if we talk of as compared to the another shop floor based technique, work measurement technique, that is the time study, see, this is very unpopular, right? And it is very time consuming, very costly also, and it is certainly not that good in terms of the environment it is in which it is conducted. Why? Because it uses the stopwatch. So work study man will be standing in front of the worker who is being studied. People don't like this, to work in this kind of condition. Once the time is identified, the work study man will also be rating his performance, how good he is working. So stopwatch time plus identification of the performance rating of the worker, these two are clubbed actually to find the normal time. Okay, and this normal time is added with the allowances. So allowances is a kind of negotiation kind of thing between the worker and the management. So performance rating is subjective. One work study man can say it is 110% rating or 90% rating, depending upon his concept of the standard performance. So this is very subjective. That is why it is very controversial also. A lot of negotiations are needed to come out with the kind of allowances which will be provided on the normal time, and the stopwatch timing. This is also a difficult one, because the study man is standing in front of the worker who is being timed. This makes him uncomfortable, and he may not be able to work in a normal rhythm, in normal way. So he may commit mistakes also. So this approach of the time study of work measurement is not that popular, or is especially among the workers. As compared to these undesirable aspects and subjectivities, uh, this work sampling is somewhat better. Okay, it is more acceptable, it is more useful, because you can conduct the studies over a long period of time, maybe number of hours, days, even months also, depending upon the nature of work to be studied. Okay, so this is just the this was the comparison of the work sampling with the another shop floor based work measurement technique. Okay, this was developed at British Cotton Research Association somewhere in 1934 by one work study man called Tippett. Okay, he had developed the idea of the work sampling, and over a period of time the same idea has been used, exploited for work measurement in under the number of headings or under the different names. So work sampling may also be termed as therefore may also be termed as activity sampling. This is one. Then random observation method. These are the various features of the work sampling. Random observation method, because all the observations in work sampling are carried out at random times. Activity sampling, like whether something is in action or something is idle, and then what are the regions of the same. Those activities, things are in action or idle, is sampled. So we try to get idea of what kind of activity is happening. Then there is a snap reading. Another name is snap reading method of the work sampling, and this is another typical feature of the work sampling, wherein the work studyman will just go in the shop floor and at a glance he will see what is happening. It's just like clicking the image of the shop floor and analyzing the same. So at a particular instant, what is happening in the shop floor, that is snapped, that is observed, and that is why it is also called snap reading method. Okay, then there is one more term. Whatever the observations are taken, ratio of that is obtained with respect to the total number of observations. So this is also called as observation ratio study. Observation ratio study. Say 5%, 5 times out of 50 observations, 5 times it is observed that the job is not being done. So the percentage idle time, like 5 by 50. So you may say, okay, 10% of the time the job is not being done or the worker is idle. So that's why it is also called observation ratio study. Okay, so these are the different names by which it is known. Now, what is the basic logic or the fundamental principle on which it is based? So as I said, in the work sampling, number of observations of the study area is made. Okay, and then number of observations of the study area is made at random instants, random time intervals at different instants. What is happening at number of observations, instantaneous observations are made of the study area at random time intervals. So there is no fixed way when the observations will be made over the study period. And in these observations, what we try to find out the status of the system with regard to whether it is working or it is idle or any other thing that is to be observed based on the objective of study. So say study is of the 480 minutes, like say 8 hours, and during the 8 hours say 100 observations are being taken. So these 100 observations will be taken at a different intervals. So at a particular observation, what is the status of the system which is being observed, which can be the working of the operator, which can be working of the machine, which can be the movement or any other aspect that is as per the interest of the study. So status of the system is observed at each observation. Whenever the study area is observed, at every observation at that instant what is happening of the with the system. So what is the status of the system when it is being observed, whether it is working or it is idle. So based on this percentage of observations of an activity, this is identified out of total observations. So like say 20 observations are there out of 100 in which nothing is being done. So the idle percentage is expected to be 20%, or remaining 80% of the time the worker is working. Okay. So that is how we try to estimate the percentage of the time worker is working, machine is working, or the worker or machine is idle. So that percentage of the time is used to calculate the actual time being used in a study, actual time being used for the production purpose. Okay, I'll give very simple example. Like say there are 480 minutes of the total work period. Okay, so if it is observed that the idle time percentage idleness is 10, which means say if you just do the minus of the rest period, so 440 minutes is the actual time during which work is done. And out of that, if 10% is the idle time, then 440 minus 44, so means 396 minutes is actually work is being done. This is the actual working time. And in this actual working time, if the worker is producing say 10 pieces, then the actual time required for producing per unit item, it will be like 396 divided by 30. So this is how the time required to produce 1 unit can be identified, and this can be added with the allowances to set the time standard. Okay, so we try to find the working percentage, actual working percentage, or the percentage idle time. So here we don't take the stopwatch and stand in front of the worker, but the snaps of the study area are captured at the different time, random time intervals, and analysis of those observations is used to find the percentage of occurrence of activity or of the event. Okay, so what we do basically, how it is defined. See, if work sampling is to be defined, it's a method of finding the percentage of occurrence of certain activity. Now this activity may be working or maybe idle or anything that is of our interest for the study. Okay, since we are trying to quantify the work measurement, so basically we'll be most of the time having whether the system is working, worker is working or not, or he is idle, so that the actual work content in terms of the time can be quantified. Okay, so this method primarily what it does, it is the method of finding the percentage of occurrence of certain activity, whether the system is working or it is idle, based on and using the principle of the statistical observations, using the what we call it statistical sampling and random observations. So what it does, basically finding the percentage of occurrence of certain activity based on the statistical sampling and the random observation in the work sampling. Okay, so since it is based on the principle of the probability, so it gives us that the extent to which, what the probability extent to which an event is likely to occur. Okay, so it will be like, because this is the estimate of 10% idleness or 90% of the time the system is working, but what is the degree of confidence in this observation, whether this kind of the observation is being made based on the just 10 and number of the observations of the shop floor or 1000 number of the observations of the shop floor. So we'll have to see really what is the degree of confidence we have in this percentage of occurrence and what is the possibility of error in our observation. So we'll have two things like confidence level in our observations and the kind of error which is possible in our observation. So using this, so this will to a great extent depend upon the number of observations. Fewer the number of observations, lesser will be the confidence level, greater will be the possibility of the error. So how to understand this confidence level and the possibility of the error? For this we have to see a simple example. Example goes in like this. Let's take 5 coins, okay, and go for a toss and try to see what is the probability to have the different combinations. Like what is the probability to have all heads are falling with the 0 tail. Okay, then what is the probability, or what will be the, how many times, just go for toss of 5 coins in one go and see how many times we get all 5 heads and 0 tail, or 4 heads 1 tail, 3 heads 2 tails, 2 heads 3 tails, 1 head 4 tails, 0 head 5 tails. So what is that, how many times we get these different combinations? If the toss is done just for 10 times or 100 times, so say the 5 coins are tossed 100 times, then the kind of combination which comes out to be like this. See, the 5 heads and 0 tail are observed, number of observations. How many times it is happening? Just 3 times. Similarly, 0 head and 5 tail are observed again for 3 times. Then 4 heads and 1 tail is observed 17 times. 1 head and 4 tail is observed for 17 times. Similarly, the 3 heads 2 tails are observed. This is the combination that is observed 30 times, and this is also observed 30 times. Okay, so since we are just doing the toss just for 100 times of 5 coins, and we are trying to see what is the possible combinations and how many times those combinations can happen. So we start with the 5, say head and tail, right? So here 0, 4, 1, 3, 2, 2, 3, 4, 1, 4, and 0, 5. Okay, so the kind of the plot which is coming, number of observations here, number of observations. So here say up to, say here it is 40, then 30, then 20, and then say 10, right? So 3 and 3, this is the kind of number of observations that we have. Then for 4 it is, say 17. Okay, so 17 and 17, right, like this. Then 30 and 30. So if you see, just 100 tosses and the kind of distribution of the different combinations which is coming in like this, and this is by and large, this is corresponding to the normal distribution. And if this number of the tosses are increased to 1000 or more, then what will happen? We will be getting the more clearer distribution of these different combination of the observations, and it may be very, very smooth like this. Okay, say here 40, and again the similar kind of thing, but the distribution will be more smoother. So this will be indicating that possibility or the tendency to have the combinations 3 or 2, 2 or 3. These two combinations will have the highest probability. Okay, highest tendency or the number of observations will be corresponding to these two, and the number of observations corresponding to these extremes will be very less. So how to quantify this? And so for this only we have to use the statistical principles, and when it is plotted, it comes out to be like this, the different combinations, right? And here the maximum tendency to have a combination of 3 2 or 2 3 of the tossed coins, this is the kind of the number of combinations that are received maximum here. And when the number of tossing is increased significantly, we find that our curve is much more smoother. Okay, so this curve is called the normal distribution. So if you see what is the possibility for having, so this normal distribution curve is characterized by the two things. One is the central tendency of the data. Okay, central tendency, where the most of the data is trying to fall in. So that is obtained from the average. So this X bar shows the average. And what is the tendency of the data to fall away from the center value? So that is indicated by the deviation, or commonly known as standard deviation. Okay, and that is shown by this spread. Okay, about the central data value. So whether it is falling within the 1 sigma band, that is close to the center, or 2 sigma band, or 3 sigma band, both the sides of the central value, that will indicate is how much spread we are looking for. What is the tendency of the data to fall within the 1 sigma band, or the 2 sigma band, or 3 sigma band. Okay, so this is what we get from the normal distribution curve, and you know about this. Let me erase all these if possible. Okay, so here you are very much aware of this statistical principles and the normal distribution. So about the center value or about the average value, when the spread is of the 1 sigma, it covers an area of about 68.27. When spread is of the 2 sigma, it covers the area under the normal curve of this 95.45, and when it is of the 3 sigma, when the spread about the average is of 3 sigma, this covers the area of 99.73%, so which indicates that what we are looking for and how much spread is being considered in our study. So this indicates if the values are in this range, with respect to the average, then we are trying to see what is the tendency to fall the data in this 1 sigma band. Then this will indicate, okay, 68.27 is the kind of the possibility of when the data will fall within this band, or it is so indirectly we say that the confidence level is 68.27 to have the data within 1 sigma spread about the average value, and likewise for 2 sigma it is 95.45 confidence level or 99.7%, 73% confidence level for 3 sigma spread value. So here what we do, just for simplification, like say 95% confidence level, to indicate that the observations which are being done randomly, they will be corrected to the 95%, or the confidence level is 95% if the fall in the data values is within 1.96 sigma value from the central data value or the average value. So for 95% confidence level, we take the plus minus 1.96 sigma. Okay, and then for 99% confidence level, we consider plus minus 2.58 sigma, and for 99.9% confidence level, we consider the sigma value of 3.3 sigma. Okay, so just for a simplified situations, 99% confidence level or 95% confidence level, the different sigma values are used. So corresponding to 1, 2, 3 sigma, these are the confidence levels, and for a standard confidence level like 95, 99 or 99.9, these are the sigma values which are considered. Okay, so now we'll go a little back to the our so here we have to end actually, so I'll go back to our so I'll be using this whiteboard again. Okay, so after this so if you have seen that when we take the fewer observations, the confidence levels may be low and the possibility of error in observation may be high. So how to identify the number of observations should be taken so that our confidence level on the observation is high and error is low, and that too as per our requirement. So there are two things, like identification of number of observations to be taken by visiting the shop floor or taking the snaps of the shop floor. Number of observations n is to be taken for given or desired confidence level of 99 or 95%, or for a possible error in the observation allowed is say just 5% or 10% error. This is called, like, allowed error in the data is 5% or the 10%. So considering these, we determine the number of observations to be taken for the work sampling. So how to do the work sampling? I will talk little bit first about the procedure of the work sampling. There are three main steps. One is prepare for the sampling, then second is perform sampling, and then evaluate the data collected for after the sampling. So when we talk of what is there in preparing for sampling, this is very crucial to understand when and what will be said as far as the observation is concerned. So depending upon, so identify first what is the objective of study, what you want to determine. It is the idleness of the worker, idleness of the machine, or working of the machine, working of the worker, or the percentage of the time particular machine is idle, due to the particular reason, or the particular worker is idle due to the particular kind of the reason. So objective of the study with the clarity has to be identified. This is one. Then before conducting a study, you need administrative approvals of the authorities of the shop floor. So approval of the foreman, of the manager, or the manager is needed. Then how it will be quantified? So the parameter which will be used to quantifying measure, parameter, how it will be quantified, how activity will be quantified. It is just in terms of the time or number of units or something else. Then it is also important, like who will be studied. So select the man or machine or the process to be studied, that has to be fixed, and then make a detailed plan of, like, who will be doing, how will be doing, when it will be done. So detailed plan of the study. Okay, these are about the preparation stage, and then performing is the another, that is furthermore important. First, let's say classify the elements. It is just the worker, or worker and machine, or machine is working but a machine is working, or it is idle, or idle then due to what it is idle, maybe due to lack of material, due to the maintenance, or due to the some other reason. So classify the different elements related with the study. Then design the suitable design observation forms. So as per need, suitable forms, there are a variety of forms. I will show you some of the forms which are used. Then the number of days, shifts of study are identified, okay, when the study will be done. Then another important thing, when the study will be done, related with this only, what are those randomized times when study will be conducted. So they like say the first study observation is done at 7:10 in the morning, like 7 to 4 shift, or 8 to or 9 to 5 shifts, so depending upon the case. So 9:10 is the first time. Then what is the next time of the study? It is like say 9:50 or 11:20 or some other. So randomized time values are identified depending upon the number of observations are to be taken for a given confidence level and for a given error, allowed error in the observation. So randomized time values are identified. Then take the observations. Visit the shop floor or capture the image or record the image of the shop floor and analyze this later. Obviously, since these there are number of observations to be taken, maybe too many, so in each day whatever is the summary of the observation that is to be obtained, like each day what is the performance, because this will be used very effectively when I will talk little later. This is an iterative process of coming out to the desired with the desired results. So summarize the observations and then use it again for further studies. Okay, how it is done I will talk a little later. Then evaluate. Whatever the observations have been obtained, let us evaluate and check the validity or reliability, how good our data is and what is the confidence level, how much error and what is the result. Okay, then make the presentation or the analysis of the data and then based on this future plan. So these are 3 steps of preparing, getting ready for the work sampling. Okay, now coming back to the step-wise procedural steps for conducting the work sampling, how it is done. Okay, so there can be various situations, like you take a 10 samples from a lot of 1000. Okay, so out of a lot of 10,000 you have taken 10 samples and you found 3 defective in one case. Another lot you have taken, you found 4 defective. Another sample you have taken, there is 1 defective. So your p value will keep on changing. This is an iterative process. So how many, at least the number of observations you should make, so that you have some representative value of the entire lot which is being studied. Okay, so when you have the idea of the percentage of occurrence is this much, then that is good. But if it is not so, then from somewhere we have to start with the random value. Okay, so say average defective after, let's say, studying the 200 samples of a lot size of say 1000, you have found, okay, 4% is the kind of the percentage defective item is 4%. Then this will be the p value, like 4% is the defective item or 4% is the time for which the system is idle. But initially the initial observation showed you 3% idleness, third observation showed you 1% idleness, second observation showed you the 4% idleness. So when you have no idea of the kind of representative percentage occurrence of the entire lot, then from somewhere we have to start with. So what is done? So this you can say rough or initial stage observation percentage. This is shown or indicated as a P1. P1 is instantaneous observation percentage, okay, of a particular sample size. That is fine. But this may not be the true representative of the percentage of occurrence of the real situation over a long period of observations. So actually it is P, but initially you got it P1. So how close or how different P and P1 are, that is indicated with the help of standard deviation and standard error. So these are actually related using a particular equation. So standard deviation P, sigma P, is quantified using the equation P1 minus P divided by N minus 1. So N is the sample size, like you are taking 20 number of observations and the percentage occurrence of the 20 observation is 4. So 4 by 20 is the P value. Okay, so N is the sample size here, and P is the standard deviation in the value of the P and the P1. So how these are related? Initially the standard deviation in the value is sigma P. This is when this equation is used when the sample size is less than 30. When the sample size is greater than 30, then the equation is a little simplified and we write it P into 1 minus P divided by N. Okay. Now these values of P and P1, these are related with the help of one simple equation, and that is written as P is the percentage of occurrence that is being identified during a particular set of observations. S is the error. So here percentage of occurrence. This may be working or this may be idleness. This is allowed or acceptable error. Okay. Then K. K is the constant. K is the constant. What is this constant? Depending upon the confidence level we want it, like say for 95% confidence level it is 1.96 sigma value. Okay. Similarly it is for 66% it is for 95% confidence level it is 1.96. For 95% confidence level it is 2.58. So this is for 95% confidence level, 99% confidence level, and 3.3 sigma value. K is 3.3 for 99.9% confidence level. Okay, so this is the constant value depending upon the confidence level that we are looking for. Okay, and then sigma P is the standard deviation that is identified. So we can further write this equation as P into S equal to K into P1 minus P divided by N. Okay, so our equation becomes P into S equal to K square root of P1 minus P divided by N. Now this is what is used. K as per the confidence level desired, S is the error that is allowed, maybe 5% or 10%, P is the actual observation value, and A is the number of observations which are being taken. Okay, so based on this equation I'll give one example maybe next time, so that you have the more clarity that how it is actually done to arrive at the desired number of observations for making the study. Okay, for making the work sampling.